minus 1 hn x of n minus k. It is the equation which is present, contains finite terms. So in this case, if this is the way, then h capital M onwards necessarily has to be 0. Necessarily has to be 0. But this is not a good thing, because I am trying to ignore subsequent hn now, because infinite is not realizable. But the same I can take into consideration by some recursion which we discussed last time itself. If what I do is
recording 1.96 GB, 720 pixels HD. 720 pixels HD.
If I am able to express my yn as summation of bn, some coefficient, into previous inputs, current and previous inputs, and at least one n must be non-zero into some previous outputs. If I am able to do that, in that case, what I come to a conclusion is I am able to extend till minus infinity, till infinite samples back, because in determining current output I have taken into consideration the effect of past output. Similarly, that past output has taken into consideration effect of its past output, then it has taken into consideration its past output. So, and each past output is considering the effect of previous inputs. So I go back till infinity, and therefore this is called as, why it is called as FIR and why it is called as IR, also I will explain. FIR and IIR systems. It is called as FIR system and IIR system. Finite impulse response and infinite impulse response. That also we can very easily explain why it is called an impulse response, or what we mean by impulse response. An impulse in continuous domain is difficult to visualize. It is very much unfortunate that you are unable to maintain the complete silence required for understanding of those who really want to understand. I am not assigning any teamwork to you. You are supposed to discuss among yourselves if there is some group task is assigned to you, not otherwise. So an impulse is easy to be visualized in discrete or digital domain. That is because it is having a finite height. So xn, or that signal is denoted by a special one called delta n, which we have also discussed. Delta n is equal to 1 for n equal to 0, and it's 0 elsewhere. So only the sample at n equal to 0 is 1 and other samples are 0. Then we take only two peculiar systems. And we try to see what output will come. So I have one system 1 for which what I am having is yn is equal to x0 plus x1 plus x2. It can't be there. There was some writing mistake. Y is equal to xn plus xn minus 1 plus xn minus 2. What will happen now? If so, this is my system. So what is my hn? Means hn is equal to 1 1 1. H0 is 1, H1 is 1, H2 is 1, and 0 elsewhere. So this is my. I apply input to it and obtain output. Now, what is meaning of impulse response of the system? The meaning is, if I apply input as impulse function, what output the system will give is called as impulse response. Impulse response is that yn if xn is equal to delta n. Impulse response is that yn if xn is equal to delta n. So if xn is equal to delta n, what will yn? What is y0? What is y0? 1. What is y1? y1? 1. What is y2? 1. What is y3? y4? So it will be always 0 afterwards. So when an impulse is applied, the output becomes 0 after some n and remains 0 afterwards. For a finite impulse response system, the output yn exists and is non-zero only for finite samples. After that, it becomes 0. So impulse response is finite. Impulse response is that output if input is impulse. Now let us take next example. Hn is equal to obviously when n is less than 0, hn has to be 0 every time. Hn is equal to what we can consider half raised to n, and obviously for less than 0 it is 0. Hn is half raised to n, means what? What is my yn? Yn is, how can you write it in this form?
xn into hn.
You can write it in this form, half raised to n x of n minus k. Right? In this form you can write. You can write it in compact form also, but and if you are writing in this form, it should be always infinity, because it is always, it is hn is equal to half raised to n for n greater than or equal to 0, and it's 0 for n less than or equal to 0. So it starts with 0. So now what will y if I apply impulse as input? What is y0? Y0 would be 1. Y1 half. Y2 4. Y3 1/8. Y4 16. And thus we find that output will continue to be generated even if now input has come and gone. Right? The same expression we can reduce it in iterative form, and that is what is the way? Y is equal to xn plus, how can we write it very effectively? Y is equal to xn plus half y n minus half y n minus 1. Yn is equal to xn plus half yn minus 1. So by this way, by simple equation we can write, and since yn is containing yn minus term, right? So yn minus 1 we can write is xn minus 1 plus yn minus 2. So each this contains a consolidated effect of all previous inputs. Are you getting me? Here the problem was in writing the equation without using yn was that it was containing infinite terms. But since one previous output is also coming in the equation, it is possible that that single term contains the consolidated effect of all previous inputs. And I would like to clarify, I do not know whether to what extent you are with me in understanding this, is that this is possible only in discrete time systems and not in digital systems. This is possible only in discrete time systems and not in digital systems. That a recursive equation with only few terms, it is only two-term equation, but it is having, even if n is 10 lakh, even if n is 10 lakh, y 10 lakh must depend on what? X 10 lakh minus 1 till x0. Y 10 lakh must also depend on x0. Why? Because our current output depends upon is weighted average of all current and all previous inputs. The weights may differ. So it is possible. Let us take this simple case. Hn equal to half raised to n. We write it using yn is equal to xn plus half yn minus 1. So you get 1 half, 1/4, 1/8, 1/16, 1/30, 1/32, like that. So obviously what will happen? As you proceed, if you are in continuous domain, what should be yn? Half of previous output. Half of that. Will it ever become 0? No. Are you getting me? We are having a simple one. Hn is equal to half raised to n, and we are talking of impulse response for which we have applied input as impulse. So output would be each time half. X0 is 1. Y0 is 1. Y1 is half. Y2 is 1/4. Or when it is very simple, when if an impulse is applied, then the transfer function is the output. So yn is equal to half raised to n. Yn is equal to half raised to n. And as n grows, yn will become small but will never become 0. Yn will travel towards 0 asymptotically. Asymptotical travel means always close than before but never attaining. But in digital thing, what is going to happen? In digital thing, how will you be expressing, say, y 10 lakh, 1/2 raised to 10 lakh, right? 1/2 raised to 10 lakh, like that. So even if you may take 32-bit number, 64-bit number, somewhere when you take any bit numbers, any form it may be, exponential form, whatever form you may have, there will be the smallest number it can represent and largest number it can represent. Below that smallest number, it will be representing by 0 and not in between that. Therefore, after some n, the output which means an IIR system is possible in discrete signal processing, but when implemented in digital signal processing, IIR system automatically becomes a FIR system when we reach the limit of what we can say the finite word length effect. We are having a limit by which we can representing a number. So in discrete time, yes, every time it is half of previous, that's all. Whether the idea is clear. But the applications to which we came across do not require this much accuracy, but our idea should be very much clear. That is, even though between digital and discrete the gap is diminishing, it will never become zero. There will be always a gap, because discrete is theoretical and digital is practical. Right? In discrete, in theory, you can assume any level of small number. In practice, you can't have it. Is it clear? So, study of HN is study of these. Study of HN study of HN, various properties, means what type of HN will have what kind of effect on the signal processing, means what XN is a signal, it has got its own properties. What are the properties of a signal? Means XN is having some values, it may be deterministic signal, it may be a random signal. Even if it's a random signal, still we can study its properties. And one very important thing is that we work with what we can say, taking finite things at a time. Taking infinite things at a time, we need not work. So, when we talk of properties of Xn, we may consider Xn of infinite length if it's a deterministic signal, and we may think of Xn to be a non-deterministic but of finite length. I would like to clarify, it's a very important thing. Either we can consider an infinite sequence if it is of deterministic in nature, deterministic in type, or if ever we are interested to consider random signal, in that case it must be of finite duration. When it is of a deterministic signal of infinite duration or infinite samples can be expressed again by finite coefficient equation, a single equation of finite coefficients, and a random signal of finite length can also be expressed by finite coefficients, right? Because when I have finite length sequence, I can simply write xn. What is my equation? X0 equal to this, x1 equal to this, x2 equal to this. So if I have capital M point sequence, I will have capital M equations. But it is just beyond imagination to consider an infinite length sequence and a random one. There is no purpose, because in a very single way one can say that term at n equal to infinity will never be known to me, because it is to occur at t equal to infinity. I am trying my level best to teach. I am not aware of your learnability. We are talking of the sequence xn. It can be of finite length or infinite length. If it is of finite length, then there is no need for me to have an equation also. If I have equation, it's better. But even if I don't have, I am confident, I am sure, it is but obvious that a sequence of length m can be fully expressed by m equations. What are the equations? x0 equal to this, x1 equal to this, x2 equal to this, and that's all, a capital M equations. If ever the sequence of infinite length, in that case, it must be a deterministic sequence. A sequence of infinite length and of random nature is a useless sequence for me, because I am not in a position to consider that. So I should either have deterministic one or I should have a finite one. The best is finite and deterministic. The moderate things are finite and random, infinite and deterministic, and the worst is infinite and random. which I never connect.